Calculus BC, lesson 4.4. We're finishing the lesson, part 2. If we look at the very top of the screen, we can also use limits to determine vertical asymptotes. Now, really what we were doing before when we found every single one of these, if there was, say, for example, for number 4, a limit as x goes to negative infinity involving a value of negative 1, what you really found was a horizontal asymptote, a line, y would equal negative 1. Your curve would get closer and closer to y equals negative 1 without touching it. The same may be examined as we look at vertical asymptotes, and we can see what's happening. Now, from your days in AMA, you're probably looking at 1 over x plus 3, and you might say, well, I know there's a vertical asymptote. We learned that if 0 was in the denominator and you had a non-zero number up on top, like plug in x equals negative 3, sure enough, we would have a vertical asymptote. But we're going to examine behavior. We can do this graphically. We know that if we have this x plus 3 to the 1 power, this is going to look like 1 over x. It's that Kung Fu Fighter graph with x files. 1 over x plus 3, we're actually going to move not 3 steps to the right, but 3 steps to the left. And it only takes a moment to get confirmation that our graph looks something like that. You could always plot a couple points if you were nervous. But look here, as x approaches negative 3 from the right side, well, you can see from this right side, we're going up here to positive infinity. As x approaches negative 3 from the left side, we'd be going to negative infinity. And what if no direction was officially represented, just x approaching negative 3? Well, we have disagreement. We're going to say does not exist. Now, ironically, there's no such real number as infinity, so even for part A, you don't have an existing y value of a limit. It's just that when you have a way to describe the behavior more accurately, saying plus infinity, we're always going to do that. Now, this is a great way to approach the problem, to look at it graphically and visually. But I do want to tell you we could also have done this without a graph. Let's just say I approached negative 3 from the right, and we looked at an x-axis, and from the right side we'd be over here. Maybe like x would equal negative 2.999. Guys, if you were to substitute that in, you would get down below something very close to 0, but it would in fact be positive down below. Negative 2.999 plus 3, you'd get something positive. And 1 over positive small is positive big. You'd go to positive infinity. Likewise, if you were looking at negative 3 from the left side, you'd maybe let x equal negative 3.01 or something like that. If you were to plug that in, your denominator would be negative. It would be very close to 0. And 1 over something very small is something big, but it's in a negative direction. So I just want to show you that you really could even do this without a graph. Let's take a look at number 7. This is the volcano shape. This is that 1 over x squared shape. So 1 over x plus 3 quantity squared, another x files. We could say go 3 steps to the left. But notice when you're squaring, there's no way these fractions will ever become negative. Your fractions are always going to be positive. So we're always above the x-axis. We can say what happens as x approaches negative 3 from the right side. Well, you could say, well, you're going to positive infinity. How about from the left side? Once again, you're going to positive infinity. And what if there was no direction specified? Well, we have agreement between the two sides. We could say positive infinity. Very, very, very similarly, we could approach the problems numerically like we did before. Like say, what happens if I plugged in a negative 2.999 or a negative 3.01? At the end of the day, however, you know that that denominator will be positive after you square. So you'll have something small and positive, and 1 over something small is big. You're guaranteed to always go to a positive infinity in that regard. Taking a look at number 8. Wow, as we're looking here, 1 over x minus 2 to the 5th. Well, this is going to be an X-Files graph. X minus 2, we actually go 2 steps to the right. Goes with reverse logic, doesn't it? But this is an odd power, so we're going to have the Kung Fu Fighter graph shape. It looks something like that. And from here, my goodness, you can see, well, what happens as we're going from the left? Well, we're going to negative infinity. What happens as we go to the right? Well, we'd go to positive infinity. What if we didn't specify a sign? Well, it wouldn't exist. And of course, you could plug in values like 1.99 just to the left of 2, 2.01 just to the right of 2, and arrive at the same conclusion for each of those. Okay, I hope this is going well for you. Let's take a look at our last problem. Tell you what, when it says find the vertical and horizontal asymptotes, well, my goodness, maybe the best thing we could ever do is maybe try to factor this top. Let's see if we had x squared plus 1, and down below we'd have, let's see, a 2x and an x, but I'm going to look to multiply to a negative 2, and tell you what, at the same time, once we FOIL, we're going to have to add to a negative 3. I hope it's clear to everybody. I need to put the 1 and the 2 over here. If I would have put the 2 in the first parenthesis, that would be indicating I could factor something out. I want you to see that just for a moment. If I would have had the 2 here, there's a 2 in common. It can't go there. That would allow us to factor a 2 out. Look, as I FOIL 1x and a 4x, you'd think, how in the world can I get this to add up to negative 3x? Well, the 4 would have to be negative. So I'd have to put a minus 2 right here and put a plus 1 over here. And then you can double check that you are, in fact, going to get 2x squared minus 3x minus 2 as you FOIL that out. You do multiply 1 times negative 2 to a negative 2. As you multiply the fronts, 2x times x is a 2x squared. Well, your vertical asymptotes, you don't even really have to do a limit here. This is kind of short. Find your denominator real quickly. Find it, setting it equal to 0. You'd get x equals 2. Here, if you subtract a 1, divide, you'd get x equals negative 1/2. That's a vertical line. X equals 2. That's going to be your other vertical line. And guys, by the way, if you needed behavior, you could do one-sided limits around there to find what's happening and to see whether you'd be going up towards a positive infinity or down to the right and the left of these numbers. To find a horizontal asymptote, though, we can look at the limit as x goes to infinity. Let's do end behavior, review from the front. What's going to control the top? Well, just your x squared. Ignore the plus 1. How about down below? Just your 2x squared. These cancel out, you'll get 1/2. But to write the equation of your horizontal asymptote, you need to write y equals, and it'd be y equals 1/2.